Hello and welcome back to this lecture on finite field. My name is Smith Kumar Chaube, and in this lecture we are going to discuss about minimum polynomial. So in the very last lecture we discussed about extensor field and some of the properties of the extensor field, and during that discussion we basically defined what a minimal polynomial is. In this tutorial, in this short tutorial, we are actually going to examine minimal polynomial a bit closer. I mean, I'm not going to discuss all the properties of minimal polynomial, but I'm going to show you how to find the minimal polynomial. Let's quickly review what we learned in the last lecture about minimal polynomial. So the definition of minimal polynomial of a field element beta is simply that minimal polynomial is smallest degree polynomial. Minimal polynomial is smallest degree polynomial over GF2 such that phi of beta is equal to 0. Then phi of x will be called the minimal polynomial of field element beta. Phi x is called the minimum polynomial of beta if it is the smallest degree polynomial which has one of its root as beta. Okay, so it's the smallest degree polynomial in which you have a root as the field element beta. Okay, and this is one of the fact about minimal polynomial is that minimal polynomial of phi x is basically an irreducible polynomial. We told you that if it is a reducible polynomial, then it cannot be a minimal polynomial of field element beta. Okay, and in order to calculate field element, what we do is that we take the field element beta and we find out beta 2 to the power e. So where e is basically an integer, e is basically greater than equal to 0. Actually it is for greater than equal to 1, you can say, for greater than equal to 0. So we calculate beta square, beta 4, beta 8, beta 16, and we continue this until we find this power, one of these power is going to be equal to beta. I mean, it's going to continue, but one of these power is going to be equal to beta, and then we stop, and that power will give you the value of e, and then the phi x is simply multiplication of these factor x plus beta square plus beta 4, so on and so forth. So we are going to find this polynomial for certain field elements. So here we have a problem that find all the minimal polynomial phi x of every field element in GF2 cube constructed, actually it is GF2 to the power 4, not cube, constructed using x4 plus x plus 1. Okay, then this is basically the definition of phi x, how we are going to calculate phi x. Now the field elements are 0, 1, alpha, alpha square, all the way up to alpha 14 for GF2 to the power 4, right? And this is their power representation, and this is their going to be polynomial representation. Now we have to basically find all the conjugate of each and every element, and we are going to multiply them. Another way of seeing this formula is that you find out all the element conjugate of beta, and then you multiply them all together. So for 0 element, its conjugate is only 1, so this is going to be alone. We have only 1 in this group. None of the field elements are its conjugate. Now the second element is 1. For 1 again you don't have any other conjugate, because 1 to the power, no matter what power you are going to take, you will end up with 1 only, right? Then for alpha, we have alpha, and alpha square is going to be alpha square only. Alpha to the power 4 will be written as alpha plus 1. Alpha to the power 8 will be written as alpha to the power 8 is basically alpha square plus 1, and then alpha 16 is equal to alpha only, right? It's because alpha to the power 15 is 1, so alpha to the power 16 will be alpha. So this is can be written as alpha to the power 2 to the power 4, isn't it? Right? So E, the value of E for this group is 4, right? So using this formula now we can find out its a primitive polynomial with respect to alpha, alpha square, alpha 4 and alpha 8. For all these elements you are going to have only one minimal polynomial. Okay, so let's do that. So we are basically going to calculate x plus alpha times x plus alpha square into x plus alpha 4 into x plus alpha 8. Now I am going to multiply x plus alpha and x alpha square, and here I am going to multiply these two together. So if I will multiply this together, I will end up with x square plus alpha square, right? And then you will have alpha cube here. And if I will multiply these two together, I will have x square plus alpha 4 plus alpha 8, right, times x, actually times x has times x plus alpha to the power 12. Okay, so now alpha plus alpha square, you can see it here that alpha plus alpha square is basically equal to alpha to the power 5, and alpha to the power 4 plus alpha to the power 8, alpha to the power 4 is alpha plus 1, alpha to the power 8 is alpha square plus 1, so it is again going to be alpha square plus alpha, and alpha square plus alpha will be equal to let me see, again going to be alpha to the power 5. So in the both of these cases I am getting alpha to the power 5. So this is basically going to be equal to x square plus alpha to the power 5 x plus alpha cube times x square plus alpha 5x plus alpha 12, right? So if I will multiply, I mean, just forget about this. If I will multiply them together, this is going to be, I will multiply these two together, I will have x raised to 4 plus alpha to the power 5 x cube plus alpha to the power 12 x square. Then I am going to multiply with this, and I will have alpha to the power 5 x cube plus alpha to the power 10 x square plus alpha to the power 17, which is equal to alpha square only x, right? And the third column I will have, if I will multiply with alpha cube, I will have alpha cube x square, then I will have alpha to the power 8 x, and then I will have alpha to the power 15. Okay, so again one can see here is that you will be, the result is going to be x to the power 4 plus, now this is going to cancel each other, so this is, these two are actually going to cancel each other, so we'll have 0 times x cube, right, which is basically equal to 0. And then if we add these three together, you see here that alpha 12 is basically equal to alpha cube plus alpha square plus alpha plus 1, right? And alpha 10 is actually equal to alpha square plus alpha plus 1. So when we add alpha 12 and alpha 10, I will have only alpha cube, and then I am adding that with alpha cube, so this is also going to cancel, and we will again have 0 x square, isn't it? In the third category, you will have here this, again you see that this is again going to be alpha square and alpha 8, right? So if you add alpha 8 is basically equal to alpha square plus 1, and alpha 8 is equal to alpha square plus 1. So if we add these two together, I will have 1 times x, and then this is going to be 1. So our result here is basically x to the power 4 plus x plus 1. Okay, is this clear? So this is how we actually calculate minimal polynomial of a field element beta. Okay, here in this case beta was equal to x. It may have been x is alpha square, sorry, beta was equal to alpha. It may have been alpha square. Still the result is going to be the same. It may have been alpha to the power 4. It's going to be the same. It may be alpha 8. It's going to be the same, because all alpha square, alpha 4, alpha 8 are conjugate of each other. Okay, so let's again solve this problem for another field element, alpha cube. So for alpha cube, you see for alpha cube, the conjugate of alpha cube are alpha cube, alpha 6, then alpha 12 and alpha 24, which is equal to alpha 9. So at most you have conjugate equal to 2 to the power 4, right? 2 to the power 4. So you can have only 4 conjugates. So all these 4 conjugates are here, and we can find out what is going to be the primitive polynomial with respect to this easily. For that we simply have to multiply them together. So here primitive polynomial with respect to these 3 elements is going to be 1 plus alpha x plus alpha cube, x plus alpha 6, x plus alpha 9, and x plus alpha 12, right? So I'm going to multiply alpha cube and alpha 9, and then alpha cube and alpha 12, and then 9 and 6. It will be much easier, you will see. So let me do this different color. So we are going to have, if we multiply x alpha cube and x alpha 12, I am going to have x square plus alpha cube plus alpha 12 times x plus alpha 15, which is equal to 1, right? And then I will multiply here. This is again x square alpha 6 plus alpha 9, and then you see alpha 9 and alpha 6 multiplied alpha 15, which is again going to be equal to 1, right? So alpha cube plus alpha 12, right? Alpha cube plus alpha 12 will result in, this is equal to, you see, alpha 12 is equal to alpha cube plus alpha square plus alpha plus 1, and I am adding alpha cube there, so I will end up with alpha square plus alpha plus 1, and you see alpha square plus alpha plus 1 is equal to alpha 10. So I will write here alpha 10 x plus 1 times x square, and you see alpha 6 plus alpha 9, alpha 6 is equal to alpha cube plus alpha square, and alpha 9 is equal to alpha cube plus alpha. So I will have alpha square plus alpha, and alpha square plus alpha is alpha to the power 5. So we will have alpha to the power 5 x plus 1. It's actually simpler to put it in power form when you are multiplying them together. It's somehow less complicated. It's much less complicated than multiplying them in polynomial form. Okay, so if we multiply these two together, I will have x to the power 4 plus alpha to the power 5 x cube plus x square simply, and then here I am going to have, if I multiply with alpha 10x, I will have alpha 10 x cube, right? Alpha 10 x cube, then I am going to have alpha 15x square, which is equal to basically x square only, and then I'm going to have alpha 10x. In the third column, when I'm going to multiply it with 1, I will have x square plus alpha 5 x plus 1. Now you see alpha 5 plus alpha 10 is actually equal to 1. Alpha 5 alpha 10, alpha 5 is equal to alpha square plus alpha, alpha 10 is alpha square plus alpha plus 1. If you add them together, alpha square plus alpha is going to cancel and you will remain with 1. So this will result in 1. This is again 3 times adding x square will result in 1. Alpha 10, it's going to be 1. So here our result is going to be, x to the power 4 plus x cube plus x square plus x plus 1. So this is the minimal polynomial with respect to field element alpha cube, alpha 6, alpha 9 and alpha 12. Okay. In the similar manner, you can find out what is the field element with respect to other element. I mean, I have already covered quite a few, so you can find out rest of them. So rest of them is going to be your homework. Thank you for tuning in. I hope I have covered this minimum polynomial in detail. Okay. So once again, to find out minimal polynomial, we have to actually find out all the conjugates of field element beta, and conjugates of field element beta is basically beta 2 to the power L for L greater than equal to 0. So when this is again going to repeat by beta, we are going to find out all the polynomials, and at most maximum for any field element, the maximum number of conjugate can be equal to GF. For example, in extension field, GF2 to the power M, you have at most M conjugate element. You can't have more than M. Okay, so once you, anyway, this is just going to give you an idea how to calculate these things. Okay, so thank you for tuning in. I will see you in the next one.